And now let's take a look at graphing of secant of x and cosecant of x. So to begin with, if we go with the secant of x, well, I can use the trig identity that secant of x is 1 over cosine of x. Now, because of this division right here, that means that anytime cosine equals 0, this one is going to be undefined. So this one is going to have asymptotes. So one way to graph it is go ahead and graph cosine. So going from 0 to 2 pi, right here is going to be pi. This is pi over 2. This is 3 pi over 2. And I'm just thinking about the graph of cosine. So that would go from negative 1 to 1 on the y-axis. And then, let me use my red pen. Cosine would start here, and then it's going to hit the x-axis at pi over 2. It goes down to negative 1. It's going to hit the x-axis again at 3 pi over 2, and then it goes up to 1. And then, of course, it keeps going in both directions. Okay, so that's just the cosine. What about 1 over the cosine? Well, like I said, anytime cosine equals 0, this will be 1 divided by 0, so it's undefined. So I'm going to graph the secant with the black pen. And anytime that cosine equals 0, it's going to be undefined. So it equals 0 right here and also right here. So there's going to be asymptotes at pi over 2 and also at 3 pi over 2. And also even right here, and this would be at negative pi over 2. So there's going to be an asymptote right here also. Now because secant is 1 divided by cosine, you could take this shape and basically invert it as long as it stays within the dotted lines. So then secant would look like this. And then that part would go up forever as it gets closer and closer and closer to the asymptote. And then take this U shape and invert it, and it would then open down. So once you draw the two branches of secant, that would be the whole graph. It would then repeat. There would be another one up here, and there would be another one down here. But as far as the basic graph, this would be it, these two branches together. So the domain, well, it would be all real numbers except for these multiples of pi over 2. So you could say it would be the real numbers, except you subtract out the multiples of pi over 2. And then what about the range? So the range would be the y values. And as far as the secant graph, it would go from 1 up to infinity. This would be negative 1 down to negative infinity. So from negative infinity to negative 1, and it does actually equal negative 1 right there at pi. And then also from positive 1 up to infinity. Okay, so now I want to try that with the graphing calculator. Let me adjust the screen a little bit so you can see that better. So for secant, my calculator doesn't have that, so I have to put 1 divided by cosine. And then for the window, I'll have it go from negative pi over 2 to 3 pi over 2. So from negative pi over 2 to positive 3 pi over 2. And for the x scale, I'm going to use multiples of pi divided by 2. And the y value is negative 10 to 10, that should be fine. Now when I graph it, I'm only graphing this part, and it's not going to graph the red part, it's only going to graph the black part. And so there's the one U shape, and then there's the second one. Okay, back to this paper. Okay, so that is for secant. And then what about cosecant? So for y equals cosecant, I'm going to use the trig identity that y is equal to, so cosecant is 1 over sine. So any place that sine equals 0, this thing is going to be undefined. It's going to have asymptotes. So let's see, the sine graph going out to 2 pi. And I'll do the sine graph in red. I forgot my y-axis, need to label that. The y-axis goes from -1 to 1. So the sine graph will start at the origin and then it'll go up to 1. It's going to hit the x-axis at pi, so that means at pi and at 0, cosecant is going to be undefined because that would cause division by 0 right here. It would then go down at 3 pi over 2, it's equal to -1, and then there's one cycle of it. So every place that it equals 0, then cosecant is going to have an asymptote represented by these beautiful dotted lines. And then again, right in here, you just invert this shape. So instead of it opening down, it opens up, and it's going to go up forever. And then this one is going to go down forever. Now, if I was actually doing this on my own, I would not have made this in red. I would have made it a pencil, and then I would have erased the pencil, and then it makes me look all smart that this is the graph of cosecant, these two branches right here. So the domain. Well, at 0 and 1 pi and 2 pi and 3 pi and 4 pi, it's going to be undefined. So it's going to be all real numbers except multiples of pi. And the range is going to be the same as last time, because this is going to go from 1 up to infinity, and this is going to go from -1 down to -infinity. So -infinity to -1, and it does include -1 right there. Union from +1 to +infinity. All right, those are the basic graphs. Now let's do something a little more challenging. Like the next example, how about y equals 2 secant 1/4 x. So secant, that comes from cosine. And this affects the period. So if you were thinking about y equals 2 cosine of 1/4 x, and graph that first in red and then invert it just like I did with the first two graphs. Well, in this case, the period, which is usually 2 pi, is going to be divided by 1/4. When you divide by 1/4, you invert and multiply by 4. That means it's going to be 8 pi. And this number right here is the amplitude. So the amplitude is equal to 2. So first, in red, I'm going to graph just this function, 2 cosine of 1/4 x. The period is 8 pi, so I would need to go out to 8 pi. In the middle would be 4 pi. This would be 2 pi. And right there between 4 and 8 would be 6 pi. And because of the 2, it's going to go up to +2 and down to -2. And then I'll just graph cosine, but using the red pen. So let's see, cosine would start at the top. It would then go down and hit the x-axis at 2 pi. It would reach the bottom right here at 4 pi. it hits the x-axis at 6 pi, and then that would be 1 cycle. So whenever it equals 0, that's where there's going to be an asymptote. And it looks like I'm going to need to continue the graph. I'm going to continue it to the left so that I have another asymptote over here. Because I need to be able to flip this one upside down to make one branch of it. And then I need to flip this one, so there would be an asymptote over here, which if that's 2 pi, this is negative 2 pi. And then go like that. And there's the graph in black, these two branches, that's the graph of 2 secant of 1/4 x. So not all of the questions ask for a domain and range. I'm just going to do it one more time. So in here, it would be all real numbers except, so these are all even numbers, 2, 4, 6, except it is not all of the even numbers because it's not 4. So it would be negative 2, it would be 2, it would be 6. What would the next one be? So if this is 6, 8, then this would be 10 pi. So what's the pattern? 2, 6, 10. Well, I could simplify it a little bit and just leave off the pi for a moment. So the numbers are 2, 6, 10. So what pattern is that making? 2, 6, 10, etc. Well, this goes up by 4, and this goes up by 4. And if something goes up by the same amount every time, that means there's a linear equation and the slope is 4. So it would be 4n. So like y equals mx plus b, this would be the slope, but I'm using n as the variable instead of x. And then try that. If I plug in a number, am I going to get a 4? No. If I plug in a 1, I would actually get a 4 instead of a 2. So what if I subtract 2? So if I substitute a 1, it works right there. If I put a 2 in here, that would be 8 minus 2 is 6. If I put a 3, that would be 12 minus 2. Ah, I finally got it. It's 4n minus 2. And then all of these were times pi, so then times pi. Okay, what about the range? So this would be from 2 to infinity. This would be from negative 2 to infinity. So from negative infinity to negative 2, including the negative 2. And then from 2 to infinity, that's not infinity, Greg, that's pi. Silly. There we go. Okay, then work the opposite way. What if you were given the graph? Then find the equation. So I'll just make up a graph. Let's say this is 1, 3, and 5. And then the graph looks like this. So this is at negative 4, and this is at positive 4. So this point right here would have to be between 3 and 5, so that's at 4. And then this one is going up like this. Okay, so given that graph, then find the function that does that. So it must be that it has an asymptote right here at 3, and it's got an asymptote right here at 1. So that means that if this came from sine or cosine, it would look like this. It would go up here, and then it would equal 0 right there, and then it would touch right there. It equals 0 again. So to me, this looks like the sine graph. So the amplitude. Now when I say the amplitude right now, I'm talking about the red one. So the red one has an amplitude of 4, and it doesn't have a vertical shift because these are both for -4. As far as the x information, the period, well, it goes from 1 to 5, so that means that the period equals 4. 5 minus 1. And the formula 2 pi divided by b is how you get the period. So I could then multiply by b on both sides. That will move the b to the top right. Also divide by 4. And then reduce. So that's going to be pi over 2. Now the sine graph usually starts right here at the origin. So this one got shifted over by 1. So that means that it's got a phase shift or a horizontal shift. That it went to the right by 1. And then, like I said, it's starting at the origin and going up. That is sine. Okay, so let's see. First of all, I'm just writing the equation for the red one. So it'd be y equals, and I know that it's the sine graph, and the amplitude goes in front, and then the pi over 2, or the b, that has to be in front of the x, and then shifted right by 1 means it's x minus 1. All right, that's the graph of the red one. Now if I do 1 divided by that, that's going to make this black part right here and this black part right here. Now the 4, that's just going to stay there because it's the trig function that I want to change. So I'm going to change it to 1 over sine, and 1 over sine is cosecant. So 4, and then cosecant pi over 2 parentheses x minus 1, and then that would be the equation. Shall we check it on the graph? Let me adjust the screen. Okay, so my calculator doesn't have cosecant, so I'll have to put 4 divided by sine, and then pi over 2, and then parentheses, and x minus 1. And I want to graph just this part of it, so I'll change the window. X goes from 1 to 5, and the x scale is 1. And then going from -10 to 10 should be good. And then that should look like the original graph. I know it's dark, but you remember what the original graph looks like. And that looks perfect.